Good morning, everyone. My name is Lasana, and it's my pleasure to chair this session. The first talk will be given by Dr. Pradip from the School of Health and Biomedical Sciences at MIT.
RMIT, yes.
At MIT in Australia. So please welcome.
Professor, can you put the microphone
Side? Is that okay? Better? Okay. Morning, everyone. So, thank you for coming here. I'm just sharing my experiences teaching physics in the discipline of medical radiations in RMIT University, that is in Australia, Melbourne. So here it is, Australia in the southern hemisphere, and here is our state. It's the second smallest state in Victoria, but it's most populous in Australia. So we have got 5 different campuses in Melbourne. So our campus, that is where we teach in medical radiation, that is here, and our program is the Bachelor of Applied Science in Medical Radiation. It is a 3-year plus 1-year program. So 3-year full-time, and we have got 6 semesters, that is the teaching period, and after that 1 year intern, our students go to the clinic to do 1 whole year practice. And during this 3 years time, in each semester, they go there in the clinic for 5 weeks each. So our program structure is the bachelor degree, and after that, in the bachelor degree, you have got 3 distinct streams. So these are actually working professionals. They will go to work in the clinic as medical imaging. So medical imaging, basically, our students will become radiographer. Then nuclear medicine. These nuclear medicine stream students will become nuclear medicine technologist. They will become a nuclear medicine either for the nuclear medicine therapy and also for nuclear medicine imaging, like the PET, SPECT, and so on. Another stream we have, that is radiation therapy. So these students will become radiotherapists. They will plan the cancer treatment plan, and also they will give the radiation to the patient. So our courses are distinctive for medical imaging, so just radiation therapy and also nuclear medicine. So one thing, the first years, we have got very common courses for all 3 streams. Second years, when they go to second year, our physics become different. So medical imaging physics are mainly dealing with the X-ray, CT, etc. And when they become radiation therapists, we deal with the radiation therapy physics. So in the radiation therapy physics, we need to deal with lots of linear accelerator, brachytherapy, and so on. And in the nuclear medicine physics, they are also distinctive with, especially for nuclear medicine, nuclear physics, and so on. So our course structure at this moment, these are the course structure. Every semester they take 4 courses. So course means we call subject a course. So these are for nuclear medicine and these are for radiation therapy. So the students we have, they are very bright students. Why they are very bright and why our program is very demanding, I'm showing you in a minute. So 95% of our students are Australian local students. It's very popular to our local students. Around 5% are international. They mainly come from Malaysia, China, Singapore, and so on. So the entry level for this one is 12-year course in the school. So we call it, like in our Victoria, we call it like the Victorian Certificate of Education, or in Sydney we call it the Higher Secondary Certificate, and so on. So the entry requirement, if you look at here, to get into the program, everyone has to have successful Year 12 equivalent program, and from different states they can come, because it's the kind of very popular. From other states we get interstate students as well. For all students, mathematics, higher mathematics is compulsory, and English is very compulsory because this program needed a lots of communication with the patient and also with the patient's family. And also the communication is not only just the communicating what's the scenario, communicating the physics of radiation as well. So the chemistry or biology is needed. The students who want to do nuclear medicine, they have to have a chemistry compulsory. Now, here's the question. Since all these students are doing the professional degree and the force they're using is all physics, the equipment they're using are based on physics, why physics is not compulsory here? The entry requirement, physics is not compulsory. Very recently, we have made it. Earlier, physics was compulsory. When physics was compulsory, we were not actually getting very quality students. What is the problem? We looked at it. The problem is, in the school, in Australia, physics in school is not very popular. So why is not very popular? I did some personal investigation. Why is that? Because the attitude of the physics teachers in the school is very rough and tough. The first day they come, they just declare that physics is for smart people. If you don't understand physics, you are not smart enough, please leave my subject. So that's the attitude actually makes them very nervous, and also very bright students, they don't get very high skill in physics. So what they do, they try to get some other courses where they can get very high marks, because these marks are very important for them to get very high ATAR score. That is actually meant for them to get into the good program, into the university. So we are not getting very good physics student. But this program is very popular and very important for our national level. So I'm showing you why this program is important. For Victorian medical radiation, we have got a projection from the government up to 2030, how many professionals in this field needed. So if you look at this one, so this is for radiation therapy technologist. We are currently here. We are producing lower than needed at this moment. By 2030, we need more. So our projection is we need to have more students from now on, and still if we get more students, they will have enough job. So if we getting 2019 here, they will be graduated by 2023. So at that time, there are plenty of job for them. So that's why it's very attractive to them. For radiographer, our projection is even more, because I need to tell you a little bit here. Radiation therapy in Australia, radiation therapy is needed based on how many cancer hospital we have, for how many linear accelerator we have. For a single linear accelerator, we need at least 2 radiotherapists. For this one, radiographer needed for any single clinic we have. If we have got one X-ray machine, we need at least 3 radiographer for 3 different shifts. So in that case, we need lots of radiographer. And for radiographer to become a radiographer, it's a 4-year degree, and the physics is the core course for them. But we don't need to tell them. If we say you need to do a lot of physics from beforehand, they become very scared. And also you have got nuclear medicine also the same way. So that's why we are getting very good students. If I show you the last year's, this year intake, the last year's ATAR, that is Australian Tertiary Admission Rank, medical imaging, it was 96.4. So this was the lowest. So we have got about 99 as well. So nuclear medicine is a little bit smaller, and radiation therapy is about 91.05. So this year it can go up. So as you see, this ATAR score is very important for them in the school. So since they are not getting very high score in physics, they are not taking it. So when they don't take in, the students we are getting, they are very bright students, but there is a mix. Some students has got high school physics before, some of them never did physics before. So what they have done, after year 9 or 10, they have done some general science where some concepts of physics were taught, but not the real physics they have done. So we have got a big challenge here. So in the class, we have got few students, only a few students have done physics before, some haven't done before. So we have to have an attitude that the people who have done physics, they are not getting advantage of it, and the people who haven't done physics before, they are not disadvantaged of it. So we have to start from the scratch. So how do we do it? I want to share some experience. So these are the physics courses we teach them. Year 1 and year 2, they are common for all 3 streams. From year 2, they go for like the separate streams because some more emphasis is needed in atomic physics for the X-rays and need more nuclear physics for the nuclear medicine and so on. So, and third year, when they do CT and MRI, that needed a lot of more actually images and so on. So now the challenge is, people are very smart now, but they also know that science is a very high level journal, and then science says it's official, physics is hard. So from the beginning, they know it's official, it's hard. There is a PRL paper saying that physics is hard even for the physicist. So what do we expect? So even many years ago, when Pauli said that he wanted to be a comedian or something, so that's the thing. So some student actually sent me this one saying, what do you want? I say, a comedian plus a physicist should be a very masterpiece. So you can be a comedian as well as you can be a physicist. Let's try to be a comedian in the physics class. So what do you do? So just another issue you have, in this conference we are talking a lot about the gender issues. I show you our scenario. So this is our male and female ratio in our class. So as you see here, we are female dominant. So in this year, roughly 68% are female students and 32% are male students. So what's wrong with that? It's very good. But all our female students, they have got a kind of information from our very top school in Melbourne. That is, physics is too hard for women, according to the female physics student. So it is officially done, and then result published and shows us every single, like most of about 78% students saying that physics is very hard for women. So what about men? What about boys? Boys were all in engineering. They have done physics before. They had to do physics to do engineering, and that don't admit. I think sometimes they are not very honest. But anyway, so I got this image sent by a student to me a few years back. So I just opened it and I said, like, wow, somebody hates physics that much, but writing everywhere about the physics terms. These are all velocity, rate of change of these, everything are physics. So I asked her, how much time you spend to draw this one on your body? And then the amount of time you have spent, you could have done some better physics better. Then she said, no, this is not my picture. So I got it from somewhere else, from the web. Then she sent me this link. And I found that link. And then there are tons of these different types of things. Everybody is saying they hate physics. It's a big challenge. What to do? I looked at my department. I just joined at that time. So I looked at the department. We have got a kind of satisfactory score. And our discipline physics satisfactory score is below here, 16%, 17%. Oh man, that is a huge thing. So the person before me, she just resigned, quit. So I got her position there. So I was in a kind of what to do. Then I tried to find out, why do you hate physics? What is the reason behind it? Because they just something, we need different approach in our thing. Feynman, one of the finest teacher ever. But I found that Feynman would have failed to teach this student because they don't like this kind of equation. They don't like this approach. On any physics, we start with matter and then we explain from there and so on field. But they don't like it. So what they do, they don't like it. But this kind of machine, very complex machine, they love it. They want to use it. They love this one. They love this one. And also, these complex, the linear accelerator, they love this one. They love CT machines. They love everything. So, but this kind of thing, very simple X-ray circuit, they hate it. So here is the thing. I got it. What to do? So we need to show them where you applying your knowledge. So from the beginning, I start with this. Okay, this is your profession from 4-year time. Now you will be working here. You will be dealing with this machine and so on. Suppose for radiation therapy people, you need to know that okay, a person coming to you have cancer. How did you know that? Okay, you have got the diagnosis. So you need to have a diagnostic tool. How did you use that diagnostic tool? That is X-ray. What is X-ray then? Okay, from where it's coming? It's coming from the atomic level. So what is atom there? Okay, atom comes here. So how it works in turn? So we do the photoelectric effect and so on. So we go from here to there, they feel interest. And every now and then, every lecture, I have to tell them why it's needed, why it's important, why it's there. So within 30 seconds, I'll finish it. So this is the thing we do. We give them a lot of material to do their own time, own pace, and then my door is open all the time, so I have to do some extra work. Another thing, we need to have a kind of like push and encourage. So that actually valued by the students. So in conclusion, we can say our students actually wants to see where they apply their knowledge, why this knowledge is important for them, and why they can get it by doing it. So I acknowledge I got an award for Teaching Impact to actually come here, and I want to acknowledge that one. And thank you very much for listening.
Thank you very much for this nice talk. Questions? Yes.
I'll try to speak up. I appreciate your tremendous efforts in getting the students to understand the underlying physics. It's a challenge that we all have and we cannot give up. I mean, students working in the medical field have to understand the physics, or else they will not be able to do the jobs properly. You mentioned very early on that you get about 5% students from other Asian countries close by. I just would like to understand that aspect, because it's very relevant here in Africa. We often see a need to train students from north of our boundaries. So do you provide funding for these students? And generally speaking, do these students remain in Australia, or do you encourage them to go on back and to try to contribute to development of their own countries?
Yeah, for the international students, for undergrad level, they don't get any scholarship because in Australia, undergraduate scholarship is like very rare. And the students we are getting from international countries, they are all full fee paying students. So on the other word, we can say they are all the rich people's children. And very currently, we are actually having another type of problem, because this student, when they come here, earlier there were positions, then they can apply for immigration to the Australia. So that's why they were very attracted to this type of program. But now the government has actually changed that one. So this, because we want to Australian government wants to produce their own. So what they are doing now, they're saying, okay, we need these, so we are actually producing ours. So the international students still coming, what they are doing, instead of coming straightway to the university, they are coming to the school now. So they're starting from year 10, so they are spending more money now to be into the system. So when they are getting a local a higher secondary degree, they are like treated as a local. So they are coming into the system. So that is a problem.
Thank you very much for the nice talk. I was wondering, in order to change the perception of students with regards to physics, have you thought of involving the postgraduate students in your department? I speak by experience. So last year we have established what we call the physics club, in our physics department, and it's totally run by students because academics just don't have time. And they organize the physics ball, and they organize talks for the students and get-together functions and so on, so that the undergraduate students also get a feel of belonging to the department, not just to the discipline, but from the human point of view, belonging to some place. And you need to use, I've realized, we need to use the potential of our postgraduate students in this, because they're also they're very young and very energetic, very willing to share their passion for the subject. So I was wondering, what is the involvement of your postgraduate students?
Thank you. That is a very good approach. Actually, we have taken that one, and we are actually getting very good results. What we do, we actually have, like, our student number in 1 year is 100 roughly. So at a current moment, we normally have about 300 students and so. So what we do, we have our second years actually to help the first years. Third years are helping the first years and second years. We have got called the peer program. So basically we have got helping, and the department is open for the whole, we don't have any holidays or anything, it's just open. So whoever there, the students have got a very good bondings between them because they will become a kind of professionals. We used to have a big problem from our clinical sides. What happens, the tendency of clinics, I don't know what here, but in Australia my experience is, when these students go to the clinic to do their practice clinical things, very often their clinical tutors tell them physics is not important. They say, here is a good machine will take care of everything, all physics, because all physics is already put inside there, so all software actually taking care of all that thing. So physics is not very important. So that was one of the things. So what I did, I actually just get off my box, I just went to the hospital. They didn't like it initially. I went there, I started bugging them. Okay, tell me, how physics is not important? I just give them a challenge. If you can live just only 1 minute without using physics, I will quit everything. So initially they didn't get me. They just say, what kind of this thing? Am I using physics? Yes, you're talking, that is physics. You breathing, that is physics. So you saying physics is not important? How dare you? So they say, man, you are aggressive. Yes, I am. So then, that was like 5-6 years back. Now what happened? Our students are actually working there. After graduating, they are working there. So every time when a student gets a job, my first thing is before semester starts, I go and visit them. I just say, please, never ever say physics is not important. So that is working actually.
Okay, let's once the speaker again.
Thank you very much.